Okay, carrying on the PPE work for 2024 using the November 2018 paper 1. I'm going to fairly rattle through the last 10 questions because you didn't have to do many of these. For question 31, we will learn soon that the cell potential is equal to E of the reduction, take away E of the oxidation. We can see in the reaction that chromium is being oxidized to chromium 3+, so that's the oxidation, and the mercury in this reaction is being reduced from 2+ to 0, and so this is the reduction. So it's the reduction take away the oxidation, 0.85 take away minus 0.74 is 1.59. You will learn that that's a relatively straightforward thing to do soon enough. Which of these will react with acidified potassium manganate 7? So primary alcohols do. This is also a primary alcohol. If you look at it, whoops, I've drawn a secondary there, but that's a primary alcohol, so that would do as well. This is a secondary alcohol, so that will as well. So it's A, B, 1, 2, and 3 all do react, so the answer is D there. Which is true for benzene. It does, the NMR does show, this is the answer is D here, the NMR shows one signal, and we haven't done an NMR at all yet, so that won't mean much to you, but all the hydrogens are equivalent to each other, and there's one possible isomer of bromobenzene, the rest aren't true. I'm not going to leave that one there for now. Which compounds react to form this stuff? Now this you should at least recognise is an ester. You did learn how to make esters way back at GCSE if you remember that. The ester you're making it from is the carboxylic acid that you're making it from is that carboxylic acid, which is 4 carbons, so it's butanoic acid it's being made from, and the alcohol you're making it from is that alcohol with obviously the hydrogen missing in both cases. And so if you work that through, that's propan 2, well, if you draw that out in full, so that's 34 is D. Question 35, the reaction of hydroxide ion with an organic reagent. Now we'll look at these soon enough, but this is a primary halogenoalkane, and when they react they undergo what's called an SN1 mechanism, which we'll look at in a lot of detail and practice plenty. The key thing to spot here when you come to do this is that this one, 2-bromo-2-methylbutane, so this stuff is a tertiary halogenoalkane, which we'll learn always undergo an SN1 mechanism, so that one's wrong as well, so it ain't that. When you have looked at a little tiny bit, so you know that I don't think you have actually, so bromopentane can react with hydroxide. Now, which one would react faster, bromopentane or chloropentane? The only difference is which halogen it is. And the bromine is a massive atom. It's got a very long carbon-bromine bond, which means that carbon-bromine bond is very weak, which means it breaks easily. So this one is the faster reaction, so it ain't that. So it must be D, which it is. And all it is comparing the rate of reactivity of a primary halogenoalkane with a tertiary halogenoalkane. It turns out these react faster, which we'll learn again soon enough. So it's tertiary. What is the major product of HBr with butene? We've not done this yet, but that's what butene or butanene looks like. And when it reacts with HBr, we will learn the reasons why, but the hydrogen will end up on this carbon because it's got the most hydrogen. Well, not because, but we can remember it by remembering the hydrogen goes where they're most of the hydrogens are. If I draw it out in full, make more sense. So the hydrogen of the HBr ends up on the carbon of the double bond, which has got the most hydrogen, which is this one. So the hydrogen will end up here and the bromine will end up on the other one. We'll look at the reasons why when we study the mechanism of that. And so you end up with 2-bromobutane. So that's why B is the answer there. You haven't done anything about chiral chemistry yet. It requires you to draw this substance, and we'll learn that a chiral carbon is a carbon that's got 4 different groups coming off it. And if you were to draw that in full, you will see that there are 2 carbons with 4 different things coming off it. Okay, I'm not even going to highlight them to you, but I might do actually. It's not that one. It is that one. Let's just draw it. CH3, CH3, CH, CH3, CH3, CH, and I've drawn the rest of the chain down here for some reason. I don't know why I've drawn that so badly or taken so long over it. But that's a chiral carbon, and that's a chiral carbon. Okay, because this carbon's got 1, 2. Oh my goodness, I've even drawn it wrong. I'm just going to start again. CH3, CH3, CH. That H is attached to that carbon, which is this one. It must be late. And now this carbon is this carbon here, so it's got an H and a Cl coming off it. Before the next carbon, which is this one, which has got an H coming off it, a Br coming off it, and a CH3 coming off it. And now you can see that this carbon is not chiral because it's only got 1, 2, 3 different types of things coming off it. This and this are identical. This one's got this thing, an H, a Cl, and this thing coming off it. So this one is chiral. It's got 4 different things. As does this one. It's got an H, a CH3, a Br, and the rest of the chain coming off it. So it's got 2 chiral carbons. Okay. NMR signal. I'm not going to do NMR on the fly. We'll do that properly. We'll come to it. But the ratios simply are the number of equivalent hydrogens in the molecules. If you draw the molecule out, 2-methylbutane, there are 6 equivalent hydrogens and 1 unique hydrogen on its own. 2 of the hydrogens are the same as each other, and the other 3 are the same as each other. We'll do lots and lots of those in time. Yeah, nice uncertainty question. We all have uncertainties, right? So the uncertainty, the absolute uncertainty, you add to for change in mass. The change in mass is 20 grams. First of all, that number, take away that number. We write that to the appropriate level of precision. But the uncertainty associated with the top number and the second number, we have to add those together to get the overall absolute uncertainty. For the change in mass, it's plus or minus 0.10 grams, which is either therefore B or D. And what's this as a percentage of that? So you should be able to work out in your head that that is 0.5%. So that is the answer. Lastly, simply a knowledge question to finish off with that you haven't done yet, but you will learn that you can use X-ray crystallography to determine bond lengths and angles within a molecule. That'll do.